models are at a point, at least the frontier models are at a point where they are very, very tenacious. If you give a particular goal, if there exists a mathematical path to achieving that goal,
they'll solve it, yeah.
they'll solve it, right? It really depends on how much you constrain on those boundaries.
All that and more on today's Mixture of Experts. I'm Tim Hwang, and welcome to Mixture of Experts. Each week, MOE brings together some of the leading minds in artificial intelligence to banter through the always packed, ever fascinating news of the week. On this week's episode, we have Olivia Buzek, staff AI engineer, Kaoutar El Maghraoui, principal research scientist, AI platforms, and Ambhi Ganesan, AI transformation leader. Welcome to you all. 4 big stories we're going to cover today. We're going to talk about the Jacobian conjecture. We'll talk about Kimi K3. We'll talk about the latest launch of the Gemini Flash models. But I want to start today with sort of the story that I can just not get out of my head from this week. So earlier in the week, basically, Hugging Face and OpenAI disclosed a security incident with regards to Hugging Face's production database. And so the background of the story is basically that the blog post sort of announces that the two companies are collaborating on security, which sounds great. But the more you go digging, the security incident that triggered the collaboration is really strange. So the way the story goes, if you're not familiar with it, is basically that they were testing some sort of new models within OpenAI, and specifically doing a cybersecurity evaluation. And the model, in an attempt to cheat on the examination, attempted to get the answer key to the examination, was able to cobble together a way to get access to the open internet, even though it was operating in a sandbox. It was able to get to Hugging Face, and then it was able to crack Hugging Face's production database to get the answer key to this evaluation. And so, you know, it solved the problem, but also created this huge cybersecurity issue as the result of an internal evaluation. And maybe, Olivia, I'll turn to you first. How freaked out should I be about this? Obviously, there was a lot of discussion that, like, oh man, this is the moment where we're really in trouble. But I also had a couple friends who were like, this is strange, but kind of not surprising in some ways. So I'm curious, like, you know, what should my blood pressure look like when you think about this sort of story?
Yeah, I also am in the kind of not surprised camp, but when I look at the whole situation, I think it's a really interesting demonstration of the fact that no matter how much training we put into these things, because they are probabilistic and ultimately we are training them to be able to exhibit goal-directed behavior correctly every time, sometimes they will solve the goal regardless. If I recall correctly, they were running this particular model through Exploit Gym, which is a benchmark like specifically designed to actually activate exploits, right? So they were kind of priming it to think in this exploitative manner, except it sounds like it did not stay within bounds, essentially. So, and I'm not totally surprised about that. I think this really points to something that we've seen over and over again, which is that the guardrails we build into the models are not enough. It really comes down to what access do you actually give the model. And obviously, if it's running around finding exploits, like, it gets even more complicated than that. But it does mean
It will find exploits, yeah.
yeah, right. But like fundamentally, that model cannot, models by themselves cannot escape containment. They can only do the things that you give them the tools to do. So what that means is you need to be very careful about what sort of tools you hand it. And much as you would with a human, if you hand somebody 3 tools and they can be used theoretically together to perform a massive exploit, then you've got a problem. And we fundamentally need to treat AI models as rogue actors in that sense, not in the sense that they are definitely going to do something wrong, but in the same sense that we wouldn't hand, you know, the production keys of whatever over to a random human as well, right? This is just not something you would do, not because you think that particular human is evil, but because you don't know what they are going to do. And because we don't know what they're going to do, we have to handle it in this way.
Yeah, and I think I'd love to build on that for Ambhi. Kind of question for you was, the one lesson is what goes on in the sandbox doesn't stay in the sandbox, and I'm sort of interested in like what the future of this all looks like because I think Olivia, to your point, I actually don't know if any set of tools could be used in some novel way to create some trouble that I don't know about. And so, is the end results for some of these like the future of the sandbox? Is it literally just like an air-gapped computer? Like, so that there's like literally physically no way you can get out? Is that practical? Is that where we're going to end up with some of these evaluations? Because it seems the only way you can really assure that the system's not going to get out.
Yeah, and I think that's some of the learnings from if you look at OpenAI's post on their learnings and what they're trying to do. And I think those are some of the recommendations that when we do some of these experiments, so to speak, maybe we'll constrain the space, right? Like we're not to Olivia's point. Like if you give three tools, there is a possibility they will end up all three tools, right? If you give them 100 tools, there is a mathematical possibility that they will at some point end up using all 100 tools. So how much do you constrain the space that you give to them really matters, right? And it is a combination of what you give explicitly versus what may be available to them implicitly, right? Because if you think about what happened here, right? Um, you put a goal, and then they were so tenacious they just went and figured out a path to getting to that goal, right? So yes, yes, the model found some zero day vulnerabilities, and then it went and stole some credentials. So it did all sorts of funky things that is it's not just about what you give access, but it's also about some of the things that implicitly you should not be doing as well, right? So it's a combination of those. Um, I think that the learning from this and some of the past experiences is, yeah, models are at a point, at least the frontier models are at a point where they are very, very tenacious. They are capable of being very tenacious. That if you give a particular goal, and if there are, if there exists a mathematical path to achieving that goal, they somehow can go and
They'll
figure
solve it.
out
Yeah.
that goal. They'll solve it, right?
Hmm.
So it really depends on how much you constrain on those boundaries.
Yeah, that's right. Yeah, and it strikes me that actually the problem gets worse and worse because I guess they get more clever with the tools you give them, right? So maybe an earlier model, you give three tools, they couldn't figure out a way to break containment, but as it gets better and better, maybe it finds some novel way to do it.
But here's the flip side, Tim, right? Because I was also reading someone else, I forget the name. There was a professor who works on, you know, the intersection of physics and biology. And then he was complaining about, hey, I asked my Fable 5 model to go and solve, a three-dimensional atomic, decomposition problem. And, it ran on a 3-hour long exercise. And at some point, it just croaked and said, okay, you know what, I'm going to hand it over to a less capable model because I deem this a risk, right? So, yes, I think there's some sort of if you think about the alignment lever, I think we as an industry haven't fully locked on that alignment lever completely.
Kaoutar, I think there are still some mysteries that I think surround this story in some ways. I think a little bit about, the way we tell the story is almost, well, the models are trying to solve the problem. And so it solves the problem by doing this like weird 0 day to get out of the system and then get to the answer key. Normally I would say like the AIs tend to try to solve this problem in the most efficient way too. And so is it a little bit strange that the most efficient solution is not solving the eval, but instead to literally come up with a novel way to break out of the sandbox, compromise a production database, and get the answer key? It feels like it's a lot of work. In some ways, and I don't know. For me, there's still some kind of mystery there, right? Because it's like doesn't immediately strike me as the most efficient way of solving the problem. And I don't know. I'm curious what you think about that. And like I don't know. I'm just kind of left with like I don't know why this happened in some sense.
Yeah, it's in reasoning. It was trying to maximize that benchmark score. And as I think Ambhi and Olivia mentioned, it's trying to figure out any way, maybe not even thinking about the efficiency here, it's just figuring out how to solve the problem. So it was narrowly trying to maximize the benchmark score, but the infrastructure allowed, that narrow objective to produce real world compromise. And so it's just trying anything it can do to solve the problem at hand and maximize the score, regardless of what's the right ways or the efficient ways, from what I've seen here. But I think another thing that I want to draw our attention to is the incident response bottleneck that we saw here. If the Hugging Face initially tried to use the commercial frontier models, which blocked Hugging Face forensic queries to analyze and try to solve this due to all these safety classifiers, which flagged the payload as kind of live attack code. And then Hugging Face had to run the GLM 5.2 locally to complete the investigation. And I think that's another maybe lesson here, because commercial hosted AI guard layers often fail to distinguish an attacker from an incident responder. And the local open weights models, they become really an operational security requirement here. And so I think that's another thing that we have to pay attention to here, because blocking this analysis because it looked like an attack, and here we needed it. So then it didn't have any other solution but to use the open weight ones. And I think even, at IBM, when we look, this incident also validates why at IBM we champion open decoupled guardrails like the Granite Guardian. We're running security operations centers. When you run these things, you cannot rely on an opaque cloud API that refuses to analyze malicious payloads during a breach. So we are advocating for these open weight safety models that enterprises can run locally on premise in an air-gapped sandbox, ensuring complete sovereignty over incident response and also this zero trust agent execution. I think that's going to be also very important going forward. Because if they have access to the internet or any proxy, even these dependencies, to download these things, they will do things like this.
That's a great point. Try not to run too many evals at home. I'm newly scared about all this, and I'm going to move us on to our next topic. So this is a fun one, and I barely understand the math going on here, but it was just a very funny thing. So this story came across my social media feed last Sunday. It was like, if any of you listeners were watching the World Cup final, it was a real slog of a game. Kind of like nothing happened for 2 hours, essentially. And so I got bored and was looking on social media, and I was like, wow, everybody's not talking about the World Cup game at all. They're talking about this tweet, and I'll just read it here because it's a very funny tweet. It's an employee at Anthropic who wrote, "Hello there, the Jacobian conjecture is false thanks to my close friend Akila for asking about it, and my other close friend Fable for working during the World Cup final." And basically, like, as far as I could tell, mathematicians were just freaking out entirely about this. And the Jacobian conjecture is basically one of these sort of unsolved problems in mathematics, previously unsolved problems in mathematics, that kind of proposes like a certain fact about how functions work. And, essentially what Fable was used for was to just like find a counterexample that disproved this conjecture after decades and decades and decades and decades. And, the math community certainly was like very shocked that this could happen. One of the funniest incidents is someone, presented this example to Claude, who is like, oh my God, I can't believe this is real. Like the AI itself was shocked that it was able to solve this problem. And so what I kind of love about this is maybe two things. And maybe, Olivia, I'll go back to you because I think the first sort of thing is like, are we about to see like a bunch of people just make discoveries on their couch watching the World Cup? Like, it kind of feels like one of the strange things about this story is that like it happened so casually, right? That like this guy presumably was as bored as I was just tapping things into a computer and then like solved this problem. And it kind of makes me wonder if we're about to see a lot more of this kind of thing going forwards.
Yeah, I think it's interesting because every time that I hear about one of these math things and then I look into what actually happened, it's almost always the case that the model just tried more things than a human would. It's not that it was like unsolvable by a human. It's just that the model like tried more things, proposed odd things that you wouldn't necessarily have come up with as a human. And so I think that's very interesting. I expect there is a number of things that are kind of low-hanging fruit in mathematics as far as that's concerned. I would assume that there's some sort of class of problems, essentially, that could be described as solvable in this way. What is interesting to me. None of the results that I've seen so far, including this one, I'm similarly a little bit. I was trying to understand the conjecture itself, and I think I'm vaguely grasping it. So like
Okay.
grain of salt
Yeah, if
there.
you want to attempt an
Um,
explainer, I just have no capacity to do that.
yeah, no. I mean, as best as I could understand, and I'm, remembering back to my own calculus classes here. The Jacobian is about the movement through space of a complex polynomial, essentially, and decomposing it into those parts, right? I'm still a little fuzzy on the conjecture itself, but maybe Ambhi is nodding, so maybe you're able to understand it. Yeah. Regardless, though, I think to the point I was making, basically, I think that there's probably a number of models in this class. It's not, or sorry, a number of problems in this class. And I think it is unclear yet whether or not those will have massive impacts for us in terms of what else does this break, right? And I think that's seeing these problems in isolation getting broken is one thing. What I'm more interested in seeing is, okay, how does that impact the whole field of mathematics, right? Because usually one problem in mathematics is related to another problem in mathematics. And down the line, it has some kind of implications for the real world, right? Since, sometimes that relationship is distant for certain parts of math, but there's usually some kind of implication. And so I think what I'm interested in seeing is that part. And I do think it's interesting that when I look into how are mathematicians responding, so somebody posted like Terence Tao, famously incredible mathematician, longtime like child prodigy, and now still an incredible mathematician. The way he engaged with ChatGPT is not something you or I are capable of doing, right? So maybe someone is capable of sitting down on their couch and making up a single example that disproves a conjecture, sure, but it then, in order for that to actually have impacts on the field of mathematics, it takes somebody like Terence Tao going through, understanding the actual details, trying to deconstruct the proof, and notably, it took him quite a long session if you read through it.
Yeah, that's right. So if I reading between the lines, it seems like, Olivia, you're saying, the mathematicians are not doomed here necessarily. That like this is just like maybe one part of the set of things that mathematicians do to solve problems. I don't know. Ambhi, are you similarly optimistic? Or are you like mathematicians are in trouble?
If you look at this, what happened here, right? All you need is, when you're disproving a conjecture, all you need is one example to disprove, right? So that's all you need to do here. Um, you're not drawing upon some crazy novel insight to actually prove something. So you're doing a disproving, which, you need to figure out one concrete example to do that. The piece I think where this is a little tricky is that obviously it didn't do a full brute force of my entire polynomial space on all the, like you're trying to do, 3 dimension, 4 dimension. Like I don't think it did a full brute force search on multiple dimensions, but at the same time, it's not coming up with some crazy novel insight here. So yes, there is I think this is largely a function of somebody who is really, really capable of steering the agent and the model really well to be able to draw out some of these. And I think we are seeing more and more of that happen, right? Across different specializations and capabilities, right? So folks who have a solid grounding and expertise and taste are able to gather way more potent outputs of it. And I'm seeing that across different specialties, right? So you can take consultants, for example, right? You'll find people who know how to construct consulting storylines well, how to construct decks well. They are able to get way better outputs. Or you look at mathematicians being able to steer this, or you're looking at engineers being able to they have the the solid foundations on how I need to go and drive my, construct my code base, right? They're able to get way better output of it. So I think we're seeing that as a common theme emerge out of these.
Kaoutar, where do you think this all goes, right? So we've been talking a lot about mathematics, and I think, Ambhi, you've already opened up, I think, the discussion where I want to kind of push the discussion is, maybe math is like a very particular kind of thing where, there's this kind of low-hanging fruit set of questions where you just kind of hammer at it. You just work a little harder than a human would have time to do, and then you kind of get these discoveries. Um, do you think that's kind of generally shared? Like, do we live in a world of lots of low-hanging fruit where, humans just haven't really put in the effort? And I guess how much should we think about this as a math thing? Or is it applicable to, consulting storylines, to, writing, to, you think about all the different applications of AI. One of the things I'm trying to think a little bit about is like, how far does this go?
Yeah, I think definitely this is not just constrained to mathematics. Mathematics here is a great example when you have to search through these high multidimensional polynomial spaces, because what happens here is humans excel at constructing, these intuitive frameworks, but they struggle to search really wild, high dimensional spaces. And what this showed is AI models coupled with formal verifiers act as high-speed engines for these counterexample discovery. But of course, this is not unique to math only. Like if we look, for example, at chip design, or if we look at, these like quantum theory, or, for example, now that's, getting into quantum computing where we need to, build these algorithms. And sometimes you have to do these simulations in high dimensional spaces. So there is a lot of problems like this that are, not solvable easily by classical systems, and where you need, these multi-dimensional search and spaces to find examples, counterexamples, etc. So, and that's, where we can really use AI to help us speed that up. Because I feel the era of, for example, for math, for the solitary mathematician staring at a chalkboard for 30 years, it's kind of officially over here. Mathematics with other, fields that require these really high dimensional reasoning and search is really becoming an operational machine assisted team sports. But again, I think going to the point that Olivia mentioned, it's not just anyone can do this. So I think going to the questions, are mathematicians in trouble? No, but their work might change here because, in the Jacobian case, AI appears to have helped search for these unusual counterexamples that humans had not found for decades. But the mathematician still had to pose the problem appropriately, recognize the result matter, check the calculations, explain why it disproved the conjecture. So that human AI workflow has still not been fully disclosed. And that is still important. So that's why where you need that deep expertise, and not just in the case for math. For example, chip designs. Right now, we're looking at how do we use AI to help us, really design efficient chips. And that is a very complex problem. And especially when you do the testing, the verifications, very complex circuits, very complex systems. And, other fields also, when you have these combinatorial theories, etc., where, it's very complex. And it is similar maybe to calculators and computers. They removed, some manual work, but allowed mathematicians or theoreticians and so on to really tackle harder problems. So I think AI here could become a very powerful research partner, especially for generating candidates, finding patterns, and checking the algebra. But I think the real pressure here will be on mathematicians, is like who refuse to use these tools. So I think here we need to they need to learn how to guide AI, challenge its answers, and turn these discoveries into deeper theories. That I think will become significantly more productive if we do it right.
I just wanted to kind of emphasize what Kaoutar is saying, in the sense that I think my greatest disappointment about this era has been the degree to which people seem to only be able to see the things that we will lose and not the things that we will gain from having access to these high-powered models. mathematics, it's sort of easy to see when something gets solved, but there's as Kaoutar and Ambhi have both said, there are so many disciplines that this impacts. I see this in software engineering too, where by default it seems like everyone just said, okay, well, we're going to software engineer faster, and that's sort of the least interesting thing we could do. I imagine the number of things that we could do and try in the accessibility field, the number of things that we could do to make products more beautiful, make them easier to use, make them more interesting, make them help people learn about the world, make them less about stealing engagement and more actual value into your life. And I really think that all of those problems are equally complex to mathematics. We don't appreciate them that way because we have this whole divide between the kind of problems that are and aren't important. But I think the more we can see these as augmentation for creativity, the better off we are as a society in this world.
Yeah, definitely. And Tim, if I might add here, like feels like chemistry and materials, where you need to search through millions of possible molecules or materials, right? Suggest maybe candidate for batteries, drug discovery and biology. I mentioned chip design and engineering, where you're exploring circuit layouts, etc. Physics, finding patterns, etc. Even cybersecurity, all these vulnerabilities, attack paths, that could be, exponentially here. And medicine, I think tons of areas, climate, energy, software development, where, we definitely can harness the power of this multidimensional search powers and get some powerful results.
I feel like Tim's blood pressure has come down quite a bit now.
Yeah, I'm feeling better now. Exactly. This whole episode has just been group therapy for me, in particular. Yeah, I mean, I think that's one of the most interesting things. And we will see, a little bit like how just token prediction turned out to apply to a lot of things. I think similarly here, the question is like, how many things turn out to be just search? And it may really be more than we expect, I think. So I'm going to move us on to our next topics. Moonshot AI is out with its new gigantic, and I really mean gigantic, open source model. Kimi K3 is out. It is a 2.8 trillion parameter model. It's a little deceptive because it's MOE, and showing great performance, incredible performance against benchmarks. And actually, Kaoutar, I want to go to you first on this story, because while it's all very impressive, 2.8 trillion parameters and, giant model, I'm also kind of like, who is Moonshot trying to build this for? We're now talking about model sizes where it's not really like a lot of like a lot of enterprises can just be like, oh yeah, let me just talk to the guy and turn on this model. Like, let's just run Kimi K3. And so there's a really interesting question that's kind of looming behind this. There's been a lot of hype about the model. But Cal, did you have a theory for why Moonshot is pursuing this even as a strategy at all? Because it feels like as they get bigger and bigger, the market they're addressing gets smaller and smaller and smaller with time, and also gets more and more expensive to do these kinds of models. And so, where do you think this all goes? Like, what is the strategy they're trying to pursue here?
Yeah, that's an interesting question. So I think they are trying to compete directly with these closed source flagships like GPT, Claude, Fable, and they're trying to dominate the open weights benchmarks on these long horizon coding and agentic web development tasks. I think they're trying, my feel here is they're trying to compete in the space of these large scale agentic orchestration and so on. And, for these things, you might maybe need a powerful model like, what they've done. But the thing is, here, open source AI isn't just training proprietary models by 12 months anymore. So it's also kind of trading blows in the real time while also driving some of these fundamental architectural breakthroughs. So the efficiency here is becoming very important. For them to be able to afford to do these things at that massive scale, they have to do it efficiently. And they're looking at also basically, the architecture and also the innovation that they did in the attention mechanism. So I think that was also essentials for them to be able to do this efficiently, and also handling these long contexts. Of course, I think what I see is, what's happening in the U.S., for example. There's a lot of focus on, smaller models and these post-training, to do these things efficiently. So while they're trying to pursue these large scale, really 2.8 trillion, that's immense. And the context windows here are useless if inference costs grow quadratically, because real open source modes are created by memory optimizations and really hardware level attention efficiency that will become super important for this to be feasible or to be practical. So it's interesting to see how this is driving also architectural efficiencies that will become so important, the inference efficiency.
Yeah, and I think the efficiencies are an important part of the story. I mean, one of the funny things is, kind of in the end, it sort of seems like the entity that would be most positioned to run these open source models are the proprietary labs. Like, is that, I don't know if this is kind of where this is all going, is that OpenAI is like, well, should we just run K3 instead? Like, I'm kind of curious about, like, you're just kind of continuing to, like, even with the efficiencies, it feels like, there's maybe only a few enterprises that would ever try to do this themselves, like run K3 at scale. I guess, Ambhi, maybe, I'm curious about your view of the market. Maybe that's what they want to chase after. Like, they're looking to get OpenAI's top 100 customers. Is that kind of really where they think the market is?
I don't think the market is smaller, right? So I do think the market is still fairly untapped. Um, we really have not looked at the worldwide market. There is a lot of latent demand in the worldwide market outside of the US, where yes, the demand might be lagging by few to several months, but for sure that demand will continue to grow, right? So beyond the US, there is a huge demand space over there, which I think Moonshot might help shape up that market as well, right? So so that's on the market. I don't think the market is getting smaller. The big $1 trillion question is, how are you going to serve that market, right? I think there is no clear answer to that. To Kautar's point, right? You really cannot just go and deploy this like you would go and deploy a small machine learning model on your compute, on your local hardware, right? There is um, you'll you'll need, clusters of nodes of GPUs, and I forget it, this needed like terabits of VRAM or something, right? Like it's immense. So where are you going to get that level of compute, and how are you going to make sure that you have the right level of coupling across your models to the PyTorch or the CUDA layers to the hardware, right? So how are you going to drive all of that optimization? It is not going to be a weekend project for somebody to go and do this, right? So I think it is an open question. We don't have a clear answer on that. So I think they're chasing after that market. Um, my best guess is that they are expecting, and you saw that, right? They, as the demand spiked up, as the global demand spiked up, they did run into constraints on being able to serve it effectively, and they had to tamp down on their serving capacity. So that is very real. I don't think there is an immediate solution for them. So I think the expectation is that that constraint will get solved as some of the compute aspects get a little more streamlined. So it might be a longer term play rather than something that, I'm going to go and serve this model to my customers immediately. So it might just be I'm building this, and then as I solve for the compute problems, then I'll be able to go and serve. And as the worldwide demand picks up in, say, 6 to 12 months, then I should be in a position to serve them effectively. So it might be a longer term play.
Yeah, I agree with Ambhi. I think probably they're targeting longer play, kind of being the leading open platform for agentic intelligence, where they have to combine these frontier scale models with efficient inference, very long context, and teams of autonomous agents. Um, And so it's kind of model intelligence, costs and efficiency, agent execution at a very large scale, and also the open source adoption.
So I think there's also an argument to be made from a little bit just the spirit of open innovation. And I say that, but what I mean by that is that someone outside the pre-existing frontier labs was always going to build a super large model. The fact that they're building it in the open, I think, presents a useful challenge to the paradigm we have right now. As we've mentioned earlier this episode, there's a lot of issues when you have an API that is closed, and the people who own that API are deciding what aspects of that model you're going to have access to. All the guardrails are predetermined. There's certain types of work that simply cannot be done. The attempt that they are trying to make is that you cannot do, for lack of a better word, evil work, right? Like maladaptive behaviors via models, right? We don't want to see more of that in the world. And yet at the same time, every time that they do that, they are challenging somebody else to come up with a model that can, in fact, do those things, that isn't as restricted, and see how that goes. And there's an argument to be made that, okay, so I think currently Anthropic has shut down all ability to investigate questions of biology, I believe, with the Fable model. That means that, okay, where do biologists sit in this? In the kind of computing days of yore, a lot of these major computational engines were owned by research labs and owned by universities, and they were more in this kind of space of public good, essentially. And I think, I don't think that Moonshot necessarily has all of those like goals in mind. Maybe they do, maybe they don't. I don't know if they're getting to it on that level of philosophical, but I do think as a community, we benefit because we fundamentally need more people than just the people at a couple of the frontier labs deciding what the future of this field is going to look like.
Olivia, maybe last question for you on this segment. Should we maybe just do the quick pulse check, right? Which is, I think we're always trying to say like, well, how far behind is open source on this stuff? And I think to one of the themes that Kaoutar brought up, I mean, this is a model with a lot of innovation, a lot of new stuff is in this thing. And it feels like, should we start thinking about open source basically operating at parity with the frontier? Or do you think there's still some distance here?
I think the main struggle with the idea of open source at parity is how few people can actually check that question. And then we get back to the who actually has the compute level for this. But I see among friends, I see a lot of people reaching for, especially like lower end Kimi models and things like that, as daily drivers. And the reason that they're doing that is because they're open, because they know that they can tackle problems however they want to do it. It may not be able to solve problems in the same way, but I've seen a lot of evidence from a few different camps that lower end models can often solve the same problems that higher end models can, as long as the person driving it has a strong understanding of the problem. It may not be as fast. It may take potentially more steps. The human might learn more along the way, but it's still possible to solve a lot of the same problems. And so there's an open question then. When do you actually need to pull out the frontier models and for how many tasks could we simply use open models, which are now benefiting from the higher end models due to practices like distillation and things like that can actually, by bringing the architectures down from the higher ends, by bringing distillation down from the higher ends, we're able to make smaller models that are more effective. And I think that's really good, really important. Very notably, I was having a conversation with somebody the other day who was basically pointing out this is one of the first times in computing history that we've been actively working against efficiency. And like there's a tendency in computer science that will inevitably reemerge here that efficiency is king. Efficiency matters a lot because if you aren't efficient, it costs you a lot of money. And we've kind of been in this world where we get to ignore the laws of economics and just build. And it's all beautiful, but efficiency is going to win. And so I see that regardless of where it comes from, those improvements in the model architecture are critical. Those and all of those things will eventually come downstream to make it so that eventually the model that can be run by your phone is in fact powerful enough to do all of the things you want it to do.
Absolutely. Well, that's actually a great segue to, I think, our final quick little segment that we'll do here. Google's out with some new models as well. So they have released Gemini 3.6 Flash, 3.5 Flash Lite, and 3.0 Flash Cyber. And in some ways, I want to kind of pair these two stories together because this is also kind of the same story, but flipped, right? Which is you have big company Google, like they just sit on so much compute. They should theoretically be doing like the biggest, most gigantic models. As yet, one of the big things they're touting here is smaller, faster, more efficient. And so it's almost like, whereas Kimi seems to be like going way bigger than you expect. I kind of look at this and I'm like, oh, why is Google going way smaller than I'd expect? Maybe I'll kick it to you. Like I'll maybe start with the same question we had for the Moonshot story is like, what's Google's strategy here? Like, shouldn't they be the ones trying to kind of say, we have the frontier, you should buy a proprietary model, we're competing with OpenAI, Anthropic. But as yet, we're talking smaller here.
Yeah. So I think it ties directly to what Olivia was talking about, right? In terms of efficiency. So at the end of the day, if you think about where all of these models would plug in, right? So primarily it's going to be either in the Gemini app, in the spate of Google's products, or directly, the big stream of consumption is from enterprise customers, right? Now, again, we talked about market demand. There is a whole lot of latent demand, we said, right? The same is true of also penetration, right? If you think about the adoption, so I'm going to generalize just AI as a technology, right? There are reports suggesting that the adoption levels is still very, 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 very early across the global space, right? And so the level of penetration here, and I'll go back to what I would look at on a day-to-day basis from an enterprise lens. If I look at my enterprise clients, for example, right, the level of penetration there, even though there are clients, going for AI transformation agendas, and I want to drive multiple different pillars and so on. If you look at what could be accomplished across the entire enterprise landscape, that level is still tiny. So now, if you have to go and drive an effective penetration, right, it doesn't always have to be the big frontier model. A lot of work that needs to get accomplished can be done and should be done very effectively and very efficiently with smaller models, right? We've always touted SLMs, and smaller models do have a good level of capability to be able to accomplish those tasks, right? You don't need a frontier model for even for some of the agents that make 2 or 3 tool calls and then accomplish 2-3 steps in a small workflow, right? Something like a 3.6 or a 3.5 Flash Lite can do that fairly effectively, right? So, or that category of models can still do that fairly effectively today. So broadly, right, the point here is that there is a huge level of work to be done, right? The penetration aspect is very small. So the way you bridge that penetration is not by throwing a frontier model at it, is by going for cheaper, smaller, more efficient, more effective models, right? And that way you're able to get a lot more of the workflows automated or transform, how you want to put it.
Olivia, maybe I'll give you the last word here. It seems to me that the market has gotten very messy. We used to talk a little bit in terms of like, well, open source will dominate the small models and proprietary will dominate the big models. It seems like we're now in a world where it's like, well, even in the small models, proprietary and open source is fighting. On the big models, open source and proprietary is fighting. It's just like everybody's in everybody else's market. Do you have any forecasts? Where do you think this market falls out in the end?
There's been this really interesting thing that's happened where we were all introduced to LLMs and generative AI via this chatbot framework. Ultimately, that chatbot framework is a very, very limited market, and we're seeing that. I always laugh when I think about the first year of ChatGPT usage, where they had an amusing drop off in the summertime when all the kids went home from their from school, and then they didn't need ChatGPT anymore. Chat-based UIs, I think, are actually quite limited, and it is a limited imagination of what exactly agentic behavior can be and what autonomous agents and autonomous intelligent agents can accomplish. So I think what we will see increasingly more of, and I think both the high-end labs and the open source folks are recognizing this, is that we will increasingly need to roll out little models that can solve specific tasks. And ultimately, if you're doing something like adding automation in some kind of factory, right? There's some kind of critical decision that needs to be made, and usually a human has to step in and make some analysis of all of the numbers coming in and make a split-second decision. Now, potentially, you can insert a model in that space, and the human moves on to hopefully more complex tasks that requires their input, essentially. If you're able to do something like that, you're probably, if that model is going to be useful, it's going to run so many times and that you are going to lose money if you are throwing frontier models at it. And I think most enterprise cases actually look like this. And I think it's interesting because the first year of UX design around LLMs was a lot of product managers being thrown the idea that they have to put AI into something. And they were like, well, as far as I understand, AI is chat. So I'm going to stick a chat bot in every single in every single app we release. The vast majority of those, as far as I can tell, do not get used. I do not think people are actually all that interested in a blank text box. If they were super interested in a blank text box, I'm not sure we would have apps with all these buttons in the first place. So there's sort of a different future that I think we can envision where you're ultimately interacting with your apps the same way that you always have, but because of some kind of agentic intelligence behind the scenes, those apps are smarter. You have to make less moves. You have to press less buttons. And that is actually an easier future for most people to live in than one where, in order to get a new graph out of their health app, they have to type, I would like a new graph out of my health app. I don't think anyone actually wants that.
No, I don't think so either. Well, I could talk with this crew for hours. Ambhi, Kaoutar, Olivia, thanks for joining us on the show. But that's all the time that we have for today. And thanks for joining all you listeners. If you enjoyed what you heard, you can get us on Apple Podcasts, Spotify, and we'll see you all next week on Mixture of Experts.